So we're going to revisit probability. Now, when we last talked about probability, you were given, like, say maybe you said, hey, there's a bag. It's got three orange marbles in it and two green marbles in it. And they wanted to know what is the probability of green. And so then you would count up, okay, there are two green out of one, two, three, four, five total marbles. And that would be your probability. But what happens when the counting is just a little bit more complicated? Like, for example, what if I asked you the question, there are five of you and I'm going to give three of you a piece of candy, then how many ways could I hand out candy to three of you? Like, say maybe there's Dawn, Gerald, Clarice, Nathan, and uh, Samantha. If I was going to give candy to three students, well, I could pick, Dawn, Gerald, and Clarice, or Dawn, Gerald, and Nathan, or Dawn, Gerald, and Samantha. And so I've come up with three ways that all involve Dawn and Gerald. So there's lots of ways that I could count that up. And that's when order doesn't matter. What if I said, hey, I'm going to give three people candy? One person's getting a king size candy bar, one person's getting a fun size candy bar, and one person's getting a mini candy bar. Then I could choose to give Dawn the big piece of candy, Gerald the smaller piece of candy, the fun size, and then maybe Clarice gets the mini size. And then it could be rearranged just within Dawn, Gerald, and Clarice several times. Now, these lists get very, very long. So instead of actually having to compute them yourself, I'm going to show you how to do that in the calculator. So in the calculator, you want to go to the math menu. You see math is right under alpha. Scroll over to probability. And there are two really important functions here. You see option 2 is NPR and option 3 is NCR. P stands for permutation, C stands for combination. Permutation is when the order matters, like how you got a king size candy bar or a fun size candy bar or a mini candy bar. C is when the order doesn't matter, like when we were just handing out candy. So let's let our calculator do these computations for us. Let's answer the first questions. There's five kids, and I'm going to give out three pieces of candy. So three pieces of candy are all the same, so it doesn't matter if you get candy first or last, you're still getting a piece of candy. So we're going to use combinations. So there's five kids. Always start with your whole group. We're going to give candy to three of them. There are 10 ways I could hand out those candy to kids. Now, if the candy is different, then order matters. So we're going to go over to probability and choose NPR, or permutations. And there's still five kids. But now that order matters, there are 60 ways I could hand out candy to those kids if the candy is different. So let's work a couple examples where we use permutations and combinations and solve some probability. So let's look at this first example. It says a student with the best academic records in a school are chosen for a special award. How many groups of four students can be selected for awards from the set of five high-performing students? Now, it says here they are chosen for a special award. So that means there's no difference between the awards. So that means when we have our five students and we're going to pick four of them, doesn't matter who we pick first or last. So this is a combination. So as I plug that into my calculator will tell me five, choose four. There are five ways we can hand out that award to those four students, because essentially everybody but one student gets it. How many combinations of two cards are possible? Now, if I'm looking at these two cards, well, I could pick an A and a B, I could pick an A and a C, A and a D, A and an E, A and a G, A and an F. And all of these cards are different. So that's 6 combinations that I found thus far. But does it really matter if I picked the A first or if I picked the B first for the group of A and B? Not really. So we're just going to pick 2 unique cards. We're going to pick 2. We're starting with, there's 7 cards there. But because it doesn't matter what order they're in, it's a combination. So 7, choose 2 is the way we would read that. That's 21 ways I could pick 2 of those cards. The students with the best academic records in a high school are chosen for a special award. How many groups of 2 can be selected for awards from a set of 9 high-performing students? Okay, again, this is exactly like the other problem where it's just a special award. So there's nothing special about it in the sense that it's different for the 2 students. So order doesn't matter. So we're still going with combinations. So it's going to be 9, choose 2, which is 36. How many ways can 5 runners finish a race? Okay, now this one, it does matter because it matters who wins the race and it matters who loses the race. So order matters. So now I'm going to be using a permutation. Now, it doesn't say how many ways can 5 runners out of a certain number finish the race. So we have to assume that there were 5 runners in the race and all 5 of them finished. So hooray, they were able to run whatever distance was required of them. It turns out the answer is 120. How many ways can you line up 6 people? Again, when we line up people, the order matters. So if the order matters, we're going with a permutation. We're going to take those 6 people, and it says we're going to line all of them up because it doesn't say that we're lining less than 6 of them up. So we'll go to our probability. We're going to say it's 6, permutation 6. That's 720 ways to line up. That's quite a few. A movie buff has a collection of 3 movies that she wants to watch. She's a movie buff and she only has 3 movies. Interesting. She decides to watch all of the movies today. How many different orders can she watch? Okay, so it says how many different orders. So of course order matters. She's going to take 3, permute 3. And that's going to give me 6 different ways she could order those movies. Okay, now this is starting to look familiar from the beginning of the year. You spin this spinner. After that, you randomly draw 1 marble from the collection. Now, you will remember that the spinner and the marbles don't affect each other, so these are independent events. It says, what's the probability of the spinner stopping at a brick section? So if I'm looking at this, this looks like the only brick section, so it's 1 out of 4 sections are brick. And then drawing a yellow marble. So, and we're going to multiply our probabilities, and we have 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. So if we do that multiplication, we're going to end up with 1/9. That's our chances of landing on brick and pulling a yellow. You randomly draw a marble, put it back in, and then randomly draw another marble. Because you put it back in, you're going to end up with the same number of marbles each time. So I'm just going to kind of write 2 fractions. I know I started with 4. I'm still going to have 4 on my next turn. What is the probability of drawing a purple marble? Okay, there's 1 purple. And then drawing a green marble. There's 1 green. 1/4 times 1/4 is 1/16. You spin the spinner twice. Now, if you spin the spinner, you're not going to get better at spinning the spinner. So each time, your chances are going to be out of 3 sections. Says, what is the probability of the spinner stopping on a striped section? There's 1 striped section. And then stopping on a white section. There are 2 white sections. So 2 out of 9. You randomly draw twice from the deck of cards. What is the probability of drawing a 3 and then drawing another 3 without replacing? So now I know I'm starting with 6 cards, but on my second draw I'll only have 5 because I'm not replacing. Now I started with 1, 2, 3, 4 threes, but if I took one away, because I drew it and then I didn't put it back in without replacing, then I'd only have 3 on the second go. So when I do that multiplication, I'm going to end up getting 2/5. A bag has 7 speckled pens, 5 white pens, 3 blue pens, 3 black pens, and 2 yellow pens. You randomly pull a pen from the bag, keep it out, and then pull another one out. Okay? So first I'm going to total how many pens I have. 7 plus 7 plus 3 plus 3 plus 2 is 22. Oops. I was being a little bit quick there. It says you pull it out and keep it out. So that means on my second try, I'm only going to have 21 pens. And it says, what is the probability of getting a blue? Okay, so we started off with 3 blue and then a speckled. If I took a blue out, I wouldn't have taken any speckled out, and I'd still have 7 here. I do this multiplication, and I end up getting 1 out of 22.